So we are looking at notes for section 3.4. It's called linear programming. And like I said earlier, we're going to use the type of graphs that we did yesterday, but we're going to take it a few steps further. Okay? So some vocabulary. Linear programming is a method for finding a minimum or maximum value for some quantity given a set of constraints. For example, if you were a business owner, you probably want to maximize your profit, right? You want to minimize your costs. But there are constraints. Maybe you only have limited space for storing materials, okay? Or you have a limited number of employees or time constraints. So businesses have all these constraints they have to work within, but they still want to minimize costs and maximize profit, okay? And the process of figuring out what is that best option for how many things we should make that will make those things happen. Okay, that process is called linear programming. The constraints form a system of inequalities, and when we graph those, we get the feasible region. Okay, so remember yesterday how we graphed two inequalities and we looked for where they overlapped? That overlapping part is referred to as the feasible region. Any points, any solutions within that region would work. Okay. The quantity that you are trying to maximize or minimize is called the objective function. Often this quantity models the cost or profit for a business. Okay? So our first example, it says with the following constraints, find the maximum and minimum of the objective function c equals 2x plus y. So we don't really have a context in this first one. We're just working through the process. We're given the objective function, and we'll need this when we get to the end here. But first step is to graph all of the constraints. So how would we graph x has to be greater than or equal to 2? What would that look like? Vertical line at 2. Is it solid or dotted? Solid. Okay, so we're going to have a solid line at 2. And then are we shading above or below that line? Or sorry, left or right of that line? Shading to the right? So again, shade lightly. I'm going to use different colors up here, and I'm just going to indicate that I'm shading to the right side of that line, since I can't shade lightly with the smartboard. Okay? Then, how would we graph y is greater than or equal to 3? Y is greater than or equal to 3. What would that look like? Kevin? Okay, so we need a solid horizontal line here at 3. And are we shading above or below? Above? Okay. All right, so that was the green one. Y has to be less than or equal to 6. What would that look like? Horizontal or vertical? Horizontal. Okay. Horizontal at 6. Shading above or below? Below this time. Okay. And then what about the last inequality? It says x plus y is less than or equal to 10. Okay, so we could solve for y. Let's do that in a different color. What haven't I used? Purple? So we have a starting value or a y-intercept of 10, and we have a -1 slope. Okay. Solid or dotted? Solid this time again. Okay. Are we shading above or below that? We want y to be less than or equal to it, right? So underneath, right? Less than would be underneath. So looking at the picture, we have to be in between the green and red lines, yes? But we have to be to the right of blue, and we have to be under the purple one. So the feasible region here would be this section in here. We good with that? Agree, disagree? So this is why I was saying you should shade lightly, right? You need to be able to tell what your final area is going to be. Sometimes kids find it helpful to have some post-it notes and to cover up what you don't want. For example, I could put a post-it note over here to the left of my blue line. I could put a post-it note above my purple. You know what I mean? And you're just kind of blocking off the parts you don't want so that you can see what's left. Okay? The next step, we've graphed the inequalities, we've figured out the feasible region. Our next step is to find the coordinates of each vertex. Because yesterday we said any point in this region, the yellow part, or on the lines, because they're all solid lines, any of those values fit my constraints. Okay? But if I'm trying to find a maximum or a minimum, there's going to be an answer, right? There's going to be one point that gets me that maximum or minimum. And those always are at a vertex. So when you came in today, I said grab a ruler because you have to have nice exact graphs. We want to know what are those corner points. So what would be the corner point right here? What would be the ordered pair? 2, 3. Okay, so in your chart down here, you're going to put 2, 3. Do you guys have a chart? No. Okay, in the space underneath. Yeah. You're basically going to make this chart under step 4. Because we find the vertices and then we do something with them. Okay? What about this point here? It has coordinates 2, 6. Okay, that's another vertex. How about this one? 4, 6. All right, and this one here. 7, 3. Okay, so step 1 was graph all your inequalities. Step 2, figure out where they all overlap. Step 3, find the corners, those vertices of that region. Step 4 is to evaluate your objective function. And if we go back up here, the objective function they gave me was c equals 2x plus y. Okay, so I'm going to write that in here. C equals 2x plus y. And I want to find what my value is for c at all 4 of those vertices. Okay, so for my first one, c would equal 2 times my x coordinate, which in this case is a 2, plus y, which is 3. Okay, so my objective function has a value of 7 for that one. Okay, my next corner was 2, 6. C equals 2 times my x value plus my y value. X was 2 and y was 6. So 2 times 2 is 4, plus the 6, I get a 10. Okay. Next one, 4, 6. So I've got 2 times 4 plus 6, which gets me what? Okay. And the last one, 2 times 7 plus 3. Okay. Now, we can answer the question because we said max and mins always occur at one of those points. Okay, so what is my lowest answer? All right, right here. That's my minimum, right? What's my biggest answer? That would be my maximum. So how you're going to write your answer, you're going to say there's a minimum of 7 at, and then you're going to tell me the coordinates where that happens, okay? So at the point 2, 3, and then we have a maximum of 17 at the point 7, 3. Questions on that? All right, let's try another one. It says, with the following constraints, find the maximum and minimum of the objective function c equals 3x minus y. So this first step we said was to graph all of our constraints. What does it mean to say that x and y have to be greater than or equal to 0? What? We can't have negatives. Where on my coordinate plane would I have negatives? All the other quadrants, right? So I'm really, when I see this, x is greater than or equal to 0, y is greater than or equal to 0, automatically I know I have to be in quadrant 1, right? So if you have a problem that has a lot of constraints, you maybe don't want to shade that. You might want to just make a notation on there that we're just in quadrant 1, okay? But let's go ahead and get these two drawn, okay? How would we graph this first one? And I always like to label what color it is so that I can keep them straight. Okay, how would I graph y is less than or equal to negative 1/2 x plus 4? Where do I start? Start at 4. Okay, and I'm going to do negative 1/2 for a slope. So down 1 and right 2. Solid or dotted line? Solid. Okay, shading above or below? Below. Okay, and let's do a different color. Y is less than or equal to negative 2x plus 10. So we're going to start that one at 10 and do a negative 2 slope. So down 2, right 1. All right, shading above or below? Which one? Below, okay. So remember we said that we have to be in quadrant 1, right? So we have cutoffs here, yes? And then we have to be under the blue and under the red. So does it make sense that this section here is my feasible region? Is that what you're getting on yours? Yes? All right. So what's our next step once we've figured out that area? Make our chart. We need the vertices, and then we need to figure out what our objective function is going to be. Okay? So vertices would be what? 0, 0 would be this one. Okay? How about this one? And the order that you put them in doesn't matter. You just need them all listed. That one would be 0, 4. Okay? And how about this one? where those cross. This one here. 4, 2. All right, and last one here would be 5, 0. Okay. So what was our objective function again? 3x minus y? All right, so let's evaluate each of those. 0, 0 is pretty easy. What are we going to get? All right. So we've got 3 times our x coordinate minus our y coordinate. So for my next point, I end up with -4. Okay. 3 times my x minus the y gets me 10. And last one, 3 times the x minus y, we end up with 15. Okay. And did it ask for both a minimum and a maximum? Yes. So I would say I have a minimum of what? -4 is my lowest one here, at the point 0, 4. Okay. I have a maximum of 15 at the point 5, 0. Okay. Questions on that? Okay, I'm going to pause the recording. I'm going to give you time to try that third one by yourself. All right, you can certainly check with people at your tables. All right, but let's see if you can work through the process. All right, so we've graphed our 4 inequalities. We need to be to the right of green and above blue. Okay, so we've got a cutoff here. And we need to be underneath the red and purple. So we're looking at this little section in here. Now, what makes this question harder? Yeah, the lines aren't crossing at a nice exact spot on our graph, right? I'm going to fix this one here a little bit. Okay. So in terms of finding the vertices, this is again why I color code my inequalities, so I can tell which 2 am I looking at right now. All right. So for the first one, we've got a point here. We can tell what that is, right? What are the coordinates of that one? 1, 2. Okay. And this one is still pretty obvious, right? 1, 3. Okay. The other 2 are a little harder. So for this one, let's start here. Because we know that that blue line is saying that y has to be a 2 there, right? So if we look at our purple inequality and say that we know the y coordinate has to be 2 here, what would be my x coordinate? Then we can plug a 2 in for y and get our x. Does that make sense? So I'm going to use this one. We know that the y value has to be 2 where those intersect, right? Because the blue line's at 2. Subtracting 7 gets me -5. And then dividing gets me what? 2.5? Okay, so I know that that point is 2.5 and 2. Okay? Now, we're going to do similar things for the red and purple one to find this point up here. We can make a guess. What do you think it is? It looks like 1.5 and 4. Yes? Okay, let's check that. I'm going to jot it down here, 1.5 and 4. So that point has to fit red and purple. So I'm going to go back to my red and purple lines. And I want to try that point in those 2. So if I do -2 times 1.5 and add 7, do I get 4? Well, negative 2 times 1.5 would be negative 3. Negative 3 plus 7 is 4. Okay, so it fits in the red one. How about the purple one? Oh, that was purple, wasn't it? I got them switched around here. That's all right. Trying it in the red one. 4 equals 2 times 1.5 plus 1. So 2 times 1.5 would be 3. 3 plus 1 is 4. So that is the point that's fitting those two. Okay? If it was something obscure, you couldn't tell from the picture, you can always solve this system. Take the two inequalities that I put the red box around, right? You could do a substitution, elimination method, it doesn't matter. But you could solve and actually find that point. Okay? All right, so we've got our corners now, our vertices, and our objective function was 4x plus y. All right, so let's evaluate for each of those vertices. So C equals 4 times my x plus my y. So 4 times 1 plus 2, which gets me 6. Here C equals 4 times 1 plus 3, or 7. Here I have 4 times 2.5 plus 2. Well, what's 4 times 2.5? Okay, 10 plus another 2 would be 12. And then the last one, 4 times 1.5 plus 4. 4 times 1.5 would be 6, plus 4 is 10. Okay. Are we maximizing and minimizing? Okay. So what would you give for an answer? Minimum of 6 at, let's try this again. Minimum of 6 at 1, 2. Okay. And then maximum of at okay. Questions about the process? All right. So there is your homework assignment. You will need graph paper. I'll get some for you while you write that down.